Good day, students. Today I want to discuss on the topic on the internal resistance, terminal potential difference, and also the E.M.F of the cell. The internal resistance R of a cell is the opposition to the current flow offered by the chemicals between the poles of the cells. Okay, and you can see it. That resistance of the cell is the opposition to the current flow offered by the chemicals between the poles of the cell, and also E.M.F of the cell, called electromotive force, is the potential difference between the terminals of the cells when it's not supplying current, that is in open circuits. Okay, when you buy a battery from the shop and you have not yet used it, what is having is the E.M.F of the cell. Is that okay? And when it starts supplying, we started using it as torchlight battery, and it has now supplying current to the external circuit. In that case, is now potential, call it terminal PD, being supplied. Is that okay? Because there will be lost voltage. What is terminal PD? Terminal PD, terminal potential difference, is the potential difference between the terminals of the cell when it's supplying current to the external circuit. We're going to see it. Let's see. Look at the board. The internal resistance R of a cell is the opposition to the current flow offered by the chemicals between the poles of the cells. The internal resistance determines the maximum current that can be supplied by a cell of given E.M.F E. Okay. Electromotive force E.M.F is the potential difference across its terminals when it is in an open circuit, that is not supplying current to an external circuit. I've explained it. When you have a battery that's not being used at all, that's what is having on it is the E.M.F, which is the electromotive force. By Ohm's law, V equals to IR. I maximum, the current is still maximum, it has not been used at all, equals to E over R. This is electromotive force over the internal resistance. Thus, the more the internal resistance R, the less the current. The more the internal resistance R, the less the current the cell is capable of supplying. When you have higher internal resistance, the cell will not be able to supply more current. The less the current the cell is capable of supplying. Hence, cells of low internal resistance can supply a greater current to an external resistance than the cells of high internal resistance. Than the cell of high internal resistance. You can see the diagram. This is the internal resistance of the cell. This is the E.M.F. This is the battery that has not been used. Is that okay? This, when it started supplying current to the external resistance, let me say when you have a bulb and you connect battery to the bulb is now the external resistance. It's now there will be potential difference. Here is that okay? There will be potential drop here. Is that okay? Which is I capital letter R. Okay, but here this capital letter R I and small letter R I R. Here I small letter R, but I capital letter R. Okay, now the cell of E.M.F E supplies a current IA to an external resistance R. Then the potential difference across R, known as terminal potential difference, is given by, you can see, this is the E.M.F. This is the lost voltage. This is the terminal potential difference that is taking place here. Terminal potential difference. This lost voltage V equals to I small letter R, and you have to get the terminal PD. You remove I small letter R from the E.M.F. Okay, this is a very important formula where small letter V is the potential difference across the internal resistance R. Using Ohm's law, E, the E.M.F equals to IR, the terminal potential difference, plus the lost voltage. Is that okay? When you factorize out, I is common. You have I equals to I into bracket R plus R. Make I the subject of the formula, equals to electromotive force over external resistance plus the internal resistance. The term IR is called the lost voltage and is equals to small letter V, the potential drop across the internal resistance. This is the potential drop across the internal resistance when it has started being, when it is being used. Is that okay? When it has been connected to the external resistance, there will be loss voltage here, which is I small letter r. The terminal potential difference, capital letter V across the external resistance R is less than the EMF. Yes, it's less than the EMF E of the cell by the loss voltage. By this loss voltage, which you have E minus, that is electromotive force minus the terminal potential difference equals to the loss voltage, or we take it the other way around, E minus V, E minus small letter v, take this one here, this one become positive. Now we have V equals to E minus IR, this V equals to I small letter r. Okay, now terminal potential difference V, it is defined as the potential difference between the terminals of a cell when it is delivering current to the external circuit. The difference between terminal potential difference and electromotive force is that terminal potential difference takes place when it is delivering current to the external circuit, but in electromotive force, when it is an open circuit, not supplying current to an external circuit, that's not being used at all. Let's see example, a battery made up of two cells. Let's draw it. Made up of two cells. This is one cell joined in series. They are in series, supply current to an external resistance. You can see it's an external resistance of 5 ohm. Okay, current flows to a positive terminal, and we have, if the EMF and internal resistance of each cell is EMF 0.6 volts. Sorry, this one is 0.6 volts. 6 volt, 0.6 volt, 0.6 volt, and internal resistance 3 ohm. Okay, calculate the current in the external resistance. Want to calculate the current in the external resistance, in the external resistor. The potential difference is what you are looking for, current. Once again, in the external resistor, the terminal potential difference, capital letter V, which is I, capital letter R. We are looking for that, and we are looking for loss voltage, small letter v equals to I small letter r. That's what you are looking for. Okay, now since we have that, let's see the total EMF, E total, which is 0.6 plus 0.6, and volts you have 1.2 volts. R total, which is 3 ohm plus 3 ohm, 3 ohms, 6 ohms. Okay, the R external resistance, R1, let's call it R1, which is 5 ohm, slash R total now equals 6 ohms plus 5 ohms. Now you have to look for the current flowing in the external resistance. Forget E equals to I R1 R total. Let's say R total, R total, because we have added it where R total equals RT plus small rt plus R1. Now in this case, you have the E to be 1.2 equals 11. I times R total is 11 ohm. 11 ohms. Now 1.2 equals 11 I. Divide both sides by 11. Now the current now equals 1.2 divided by 11. You have 0.6 0.11 ampere. Now we have to look for the terminal PD. This is the first one. Terminal PD is V equals IR. What's the current? 0.11 times R, 5. That's 0.55 volts. The third one is the loss voltage, small letter V, which is I, small letter R. The current is 0.11 times internal resistance, which is 6, which is 0.66 volts. Loss voltage. This is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.